Here we have a question number 7 from the review. This is improper integral. What does improper integral means and why do we call it improper? This one is an example here. If one of the limit is infinity, that means this is an infinite kind of an integral. We call it improper integrals. Now, that can't directly be done using the integration technique. So what we do is we write the same integral, but in place of infinity, we write b. And infinity, we use it using the limits approach. We say, once we find the integral, whatever the function is, we are going to take the limit of that as b approaches to infinity. So the upper limit was supposed to be infinity. I wrote b in place of that. And once I find the integral, and then I'm going to take limit as b approaches to infinity. Now this is simple integral here. We still need to write in limit here from 1 to b, x square in the denominator, so it can be written here in the numerator by power -2. We can use power rule. Power rule is power 1 plus divided by the new power. -2 plus 1 is -1. Once we are through with the integral, we need to write the limits on the right hand side. Limit b approaches to infinity. This is actually -1, x to the power -1, so it can be written in the denominator, 1 to b. Now we put limits. First we put the upper limit minus we put the lower limit in the function. When I put b in here, it becomes -1 by b. When I put 1 in here, this becomes -1. So basically, I have limit b approaches to infinity of -1 by b plus 1. Now, only thing left to do is the limit as b approaches to infinity. This is the variable now which is approaching to infinity. You guys understand that 1 by b approaches to 0 if b approaches to infinity. So this whole thing is going to approach to 0 actually. So this whole thing gonna approach to 0. So that means we have answer as 0 plus 1. Answer is 1. So what we say in this question, that given integral converges to 1. That should be your final answer. Here we have the second part of improper integrals. The question here is 1 by x from 1 to infinity. It's another example of infinite integrals because this limit is infinity. So how we proceed is we place a placeholder b in place of infinity and we say the limit of b is approaching to infinity and the integral remaining stays the same. Now we just handle integral part as usual, writing the limit outside. Integral of 1 by x is natural log of x. We are done with the integral and it's a definite integral, so you have to write the limits on the right hand side. Remember, do not write c, constant addition, here because it's a definite integral. Limit b approaches to infinity. Now, how do we handle limits? We put the upper limit in the function minus the lower limit in the function. So natural log of b. I'm assuming b is positive because it's approaching to infinity. So I'm going to just write log of b minus log of 1. Log of 1 is 0 already. So we basically have limit b approaches to infinity of natural log of b. Now what is this? Remember, the graph of log function looks like this, right? That means as x approaches to infinity, the graph approaches to infinity too. So this limit should be just infinity. If in an improper integral, the answer of your limit is coming to be infinity, we are going to answer as the actual integral diverges. only case when we're going to answer converges is when we get the finite answer for the limit, which we are not getting in this case. Okay. Here is the next example. This one is a little different. It's still the infinite integral. Here the lower limit is infinity. So what we are going to do is replace the lower limit by an a. Upper limit is 0. And that a we're going to say is approaching to negative infinity. The function integral stays almost the same. Nothing changes in there. Now, how are we going to handle this integral though? This is two functions written side by side, so that's the product of functions. An integration by parts will be used for this kind of a problem. Okay. For integration by parts, we use the mnemonic Li8. X here is an algebraic function and Ex is exponential function. Algebraic function comes first in the mnemonic. That means the first function U is named as X and the remaining function is attached with dx to name as dv. We are going to differentiate u. Du will be 1 dx, basically just dx. And we are going to integrate dv, so v would be ex. Our formula for integration by parts is u dv is equal to uv minus integral v du. So let's write this down. We need to keep writing limit. Integral is uv. U is x, e x minus integral a to 0 of v du. V is ex, du is just dx. Okay. And once you're done with the integral, you need to put the limit. I'm going to put the whole limit at the end, so I'm going to not worry about that now. This is x ex. The integral of ex is just ex. And I need to put limits for everything now, right? As I said, I didn't do for this first part separately. First, I'm going to do them all together. How are we going to do the limits? We are going to put the upper limit first in the function and then we are going to put lower limit. Okay. When I put 0, 0 times e to the power 0 minus e to the power 0. When I put a, it's going to be a times e to the power a minus e to the power a. 0 times anything is just 0 and e to the power 0 is negative 1. So what do we have? Just negative 1 here. Minus a times ea minus ea. And we need to take the limit of that as a approaches to negative. Now this one is a power a. When a is approaching to negative infinity, it will become approximately 1 by infinity, which will approach to 0 basically. So the last one is easy. What about this one? I'm going to work it on the side. Limit a approaches to negative infinity of aea. So if you approach a to negative infinity, a is approaching to negative infinity and e to the power negative infinity is 0. So this is like an indeterminate form of the product format. So we are going to manipulate it a little bit. We are going to write it as a by e to the power negative a. Now we can apply L'Hopital's rule to it. This would look like a's derivative with respect to a. Okay, I know a sounds like constant, but because a is approaching to infinity, a is the variable 1. E to the power negative a's derivative would be negative e to the power a. So that basically is limit a approaches to negative infinity, negative e to the power a, which will approach to 0 because a is approaching to negative infinity. This is like 1 by infinity and that is approach to 0. So what I'm trying to say is that this also approach to 0. In conclusion, this whole limit should just be equal to negative 1. which is a finite number. Therefore, our integral should converge to -1. That's how you're gonna answer the question. So this is our last problem. Here, the problem is both upper limit and lower limit are kind of infinities. So we're gonna replace, first of all, this integral, split it into two by finding somewhere middle number. I found 0 to be easy one. Okay. And I'm going to replace this negative infinity by a. Upper limit stays the same and the integral stays the same. But I'm going to take a to negative infinity, approach a to negative infinity. Similarly, in the second integral, I'm going to write everything same, but the upper limit I'm going to change to some number, say b, and I'm going to approach b to infinity. We need to split it like this because both the limits are two different, negative infinity and infinity. Okay. Now, integral of 1 by 1 plus x square is tangent inverse x using our formula. The limits are from a to 0, but the limit have to be taken as this, plus limit b approaches to infinity. Integral of 1 by 1 plus x square is tangent inverse x, 0 to b. We put the limits here. Tangent inverse 0 minus tangent inverse a plus limit b approaches to infinity, tangent inverse b minus tangent inverse 0. Okay, let's notice what all this is. Tangent inverse of 0 is 0. We know that from trig. Tangent inverse of 0 is 0. That's given. As a is approaching to negative infinity, tangent inverse approaches to negative pi by 2. You can look up the graph of tangent inverse for that. Similarly, when b approaches to infinity, tangent inverse of b is pi by 2. So basically what is, when we take the limits, negative of negative pi by 2 plus the second one is just pi by 2 and minus 0 we do not need to write. We have pi by 2 plus pi by 2, which is pi. So what are we going to answer? Our given integral converges to pi. That's your final answer.